So now's the time to put it all in code. This is our algorithm that we've defined earlier, and we basically have two steps in the algorithm. The first step involves initializing two pointers, make them point to head. These two pointers will be, one of them will be the slow pointer, the other will be the fast pointer, and the fast pointer will move at twice the speed of the slow pointer. And then what we're going to do is advance these two pointers according to their speed until one of two things happens. Either the fast pointer hits a null, meaning that the list is acyclic, or the fast pointer meets the slow pointer, in which case we know we're dealing with a cyclic list, because they're in a loop and the fast pointer eventually overtakes the slow pointer. So let's put that in code. First, the prototype, the function, we need to return a code saying either it was acyclic or cyclic, so we're going to use an int for that. Call the function cyclic or not. What do we need to pass it? We need to pass it the linked list that it's going to deal with, right? So let's pass it a pointer to the head of the linked list, and this essentially defines the entire linked list because you could traverse the entire list using only that single pointer at the beginning. And then we need to just implement that algorithm that we have here. The first thing we need to do is initialize those two pointers. Let's do that right here. So first we initialize the fast pointer, make it point to head, and then initialize the slow pointer and make it point to head as well. Now you also want to make sure that you're not being passed an empty list, meaning head only points at null. So let's actually put that condition right here and return, what I'm going to return right here is return a false, meaning it's acyclic, because only in the acyclic case will you have a list that has a null in it, one null element. So we're just going to return false. And then the next thing you want to do is basically perform that second step, which is advance the pointers according to their speed until one of two things happens, and then you break on these two conditions, one of these two conditions. So let's put that in code. First thing, we're going to use a for loop for that purpose. I'm going to use an I to increment every single step, make it start at 0. There are no conditions that I'm going to put in a for loop because my conditions will be within the for loop. And then I will just increment the I. So here's my for loop. Now I need to make sure that I advance fast 2 times, and then after it advances 2 steps, then and only then will I advance the slow pointer once. So this will be my moving mechanism. Let me define it right here. So let me just put movement here. Fast pointer at every single step of the I, at every single increment of the I, it will move once. So this is how we're going to define this speed difference. And for the slow pointer, it will only move when I is going to return at every second step of I. And how do we basically define that? We could just use the modulo operation. So put it this way, and I'm going to show you what's exactly going to happen. So slow pointer only moves when this condition is met, and this condition is met is only after 2 steps. So when I is 0, 0 modulo 2 is going to return 0. If 0 is false, so it's going to skip over it and not move the slow pointer. If I is 1, 1 modulo 2 will return true, and then you will move. If I is 2, 2 modulo 2 is returned 0, 0 is false, you skip over it, and you don't move the slow pointer. So the slow pointer moves forward at every 2 increments of I, whereas the fast pointer moves at every single increment, and thereby we define the speed difference between the two. So I'm just going to put next here. And there we have it. This is the movement. Now we've defined the movement. Now let's just put the 2 conditions according to which the function or the loop will basically stop executing. So the first one would be that the fast pointer essentially hits a null, meaning it's acyclic. So fast pointer will become null. And what do? We return 0 for acyclic, meaning false. And the second condition would be that fast pointer points at the same element as slow pointer. So basically fast pointer overtakes the slow pointer. Let me just adjust that S right here. And what's going to happen is that we return a 1. And there's our function. It's complete. It does everything that we need to do.